And hello there. Welcome to this little short video that is going to help you to understand your assignment. Unfortunately, I'm not available to be at school today due to the illnesses of my house. But I didn't want to leave everybody hanging with, I don't know how to do this. So I'm basically going to go through the presentation, the CC presentation I would have gone through with you, and hopefully it does help you. On when I'm back on Thursday, because we only have 2 days to do that other lab, I don't really have extra time to go back through this, so I'm going to, on Thursday, if you need additional help, I'm going to ask you to hang around that last 10 minutes of class, and I can help you then. So let's just talk about polarity for a second, because that's what this assignment was about. And polarity has to do with the pull of the electrons into the valence shell. So in covalent bonding, remember, the electrons are being shared, right, between two nonmetals, but they're not always shared equally. And in that simulation, you should have seen how some orbitals and how that sharing that orbital works. And then in others, you can see a big orbital, and in others, you'll see a small orbital. If you didn't catch it from that, well, you can catch it from this. So when it comes to sharing electrons, the key is the electron negativity of the atom. What I have here is I've got the electron negativity values. And as we move across the periodic table, just like we learned back when we looked at the periodic trends, we see that the electron negative values do increase as we move across the periodic table. And as we move down the periodic table, they do decrease. Now we know that the decrease in electron negativity has to do with the distance between where the electrons are and the nucleus. So when we are moving down and increasing our energy level, we're further away from the nucleus, and we see that decline. Okay? So these values will come in handy when you need to calculate the difference, which will tell you if something is polar or nonpolar or an ionic bond. So we'll come back and revisit this. So now the electron negativity is the difference between the bonds. So we can have a zero difference, which is a pure covalent bond. That means the electrons are equally shared. Okay, equally shared. We can have what's called an intermediate difference, which is a polar covalent bond. And then we'll have a large difference, which is basically, we're saying that's an ionic bond. And sometimes when we calculate the values, what we may think might be a covalent bond, because you think it's a non-metal and a metal, and you look on the periodic table and you're like, oh, that's a metalloid, and that metalloid is acting like a metal, so therefore it's going to have an increased value. So just something for you to look at. One thing you should remember is you should remember the cutoff points, because there will be questions on your exam and your quiz and your final regarding cutoff points on the definitions for these. So in this class, we're going to use less than 0.4 being a pure covalent bond or non-polar. That's another term for pure, is non-polar. And then between 0.4 and 1.8 is going to be called a polar covalent bond. And anything higher than 1.8 is considered ionic. So here, when we've got, this is another way so you can see the electrons and what's going on. Ionic, we've got that transfer of electrons. Polar covalent, we have an unequal, where one of the atoms are going to have more pull, which is the more pull, it's going to make it more negative, right? As opposed to the other one, which would make that tend to be a little positive. But they're still both, their overall charge is no charge. So just keep that in mind. And then we've got our nonpolar covalent, which is equal sharing. So if I was to go through and find the electronegative values, I can look at them and compare it to my chart, which this is something you have to do. I can see that my diatomic molecules will always be nonpolar, which is considered pure because, it is going to be 0. I can see that my metal and my nonmetal, which is an ionic, is 2.03. So that, yes, that falls under that definition. And then my phosphorus monochloride is 0.97, and that is polar. All right, so your assignment for today is to look at the polarity simulation, right? And it's called PhET polarity activity. So you're going to be using a program for that. You do not need to sign up for it, though. No signing up, none. So we're going to go ahead and click on that. First, I want to just show you the questions, okay? So it says here, the first thing you need to do is explore the molecular polarity simulation for a few minutes with a partner. You're not doing it with a partner, you're doing it on your own, okay? In each of the 3 tabs, try to find all the controls and figure out how they work. So let's go ahead and take a look at this. Now, first thing I want to tell you is the real molecules does not work, so you only have 2 tabs. When we click on the 2 atoms, we basically, I want you to get acclimated to how it moves around, how you can increase the electron negativity value, and you can see the direction of the pool, partial charges, bond characteristics. We could put electron density, we could put electrostatic potential, we can turn on the electronic field. All right, so we're able to see all of this and see what's going on here, okay? And there's our electronic field. I just really like playing with that electronic field. So that's the first part I want you to do there. And then you're going to just do it. There's no question here, so that should be blank when I see it. All right, number 2 says, describe all the ways you can change the polarity of the 2 atom molecules. Well, I already sort of did that when I played around. I was able to change the polarity, right? How do I change it? Well, I use the electron negative values, right? That's how I do it, all right? Bond characteristics tell you if it's more ionic, more covalent. So by playing around with it by electron negativity, I can do that. And it lets me know all this information about bond dipole, partial charges, electrostatic, and electricity density. So you're going to define that based off of playing around with the 2 atoms tab. Next, you're going to click on the 3 atoms tab. On the 3 atom tab, it says describe any new ways you can change the polarity of the 3 atoms. So when we are on the 3 atom, any new way I can change the polarity? Well, we know we can do this. And when we do that, we also see that there's a different type of arrow, right? Because it's a molecular dipole arrow we are looking at. We have our bond arrows. We can see where the more pole is. And then we can look at our partial charges. And I just like to have the electronic field on because I just like to move these around and watch them all go the direction they're supposed to go. All right, so that's going to answer that question. I'm going to have to try to explain what bond dipoles are and molecular dipole is, and answer the question, can a nonpolar molecule contain polar bonds? Okay. And the final question you do not need to do because it's not there, but you can always try on your own with Lewis dot structures and see if you can figure it out by looking at the electron negative values. So that's really it in a nutshell. I hope this does help you, and I look forward to seeing everybody on Thursday. Thank you. Have a great day.